All right, these are two more problems from that same group we did in video 2. I'm going to attempt number 33 first. So we're given 7 minus 2e to the x equals 5. I can do this mostly algebraically, so I can set up negative 2e to the x equals negative 2, 5 minus 7. And then e to the x equals negative 2 over negative 2, which is 1. Well, the only way that can happen is when x is 0. So, or we can take ln of e to the x equals ln of 1, which means x equals ln of 1 is just 0. And if you take a look at the original problem, 7 minus 2 is 5, so e to the x must equal 1 there. So not terrible. This next one, however, is something that you might not have seen the like of before. So here we have e to the 2x minus 4e to the x minus 5 equals 0. You know, at first glance, it looks like we might want to take the natural log, but we can't take the natural log of a sum, and I mean, we can. I can take a natural log of the entire left side, but that doesn't get me anything, and taking the natural log of the right side is undefined anyway. I can move the 5 over and try it, but it's not going to work. And even if I do that, I can only factor out e to the x once and not all of it. But this is of the same form. If I rewrite this, e to the x quantity squared minus 4 e to the x to the first power minus 5 e to the x to the 0 power, all equaling 0. Now it's basically a quadratic. So you solve it in the same factoring ways you would normally do it. Instead of thinking of e to the x, think of it as just x. And we can set up and factor this. So we need e to the x and e to the x, and we need two numbers that multiply to give us negative 5 and add to give us negative 4, so that's just minus 5 and plus 1. So you can FOIL this back out. Remember, e to the x times e to the x will equal to e to the 2x. Since if we have a to the x times a to the y, that equals a to the x times y. Okay? No, that's plus. Sorry, plus, which 1x plus 1x is equal to 2x. Excuse me. Okay, so that's our factoring. Now, to solve for these, let's solve for this one. That means e to the x has to equal 5, which means ln of e to the x equals ln of 5, which means x equals a natural log of 5 in this case, comes out to 1.609 or thereabouts. The question wants us to give 3 decimal points. That's what it would be. Now this one over here, e to the x equals negative 1. Negative 1 is not in the domain of e to the x. Remember, e to the x looks like this. And it tapers off and doesn't quite hit 0. And that's 0, 1 right there. So this one's undefined, and if we take the natural log of each side, we'll show that as well, because we'd have the natural log of negative 1, which is impossible as well. So this one, not a solution.